Usually when we have to find the mean means, the first thing we need is xi. I told you a trick to find xi, is it? What is the value of xi? The class marker. Remember that one? Add these two and divide by 2. So when you add these two, 35. 35 by 2, how much? Is 17.5. After this, we don't have to really find this what is class mark. Okay. Instead of that, what we can do means, remember? Say man, what we can do? We take the class size. What is the class size? Which is 15. Okay. Add the class size. Plus 15 like. Okay. When you add 15, what will come? Which is 32.5. And then when you add 15 with this, 47.5. And here 62.5. And then here 77.5. And then this is 92.5, correct? Okay. Now we have to find the FI/XI for the direct method. But as you can see, these numbers are big. We can't multiply them. Is it? Like we can multiply, big numbers will come, calculation risks are there, time won't be sufficient. So to reduce that burden, we'll assume one of this as the mean. Usually where this mean comes from, this column or this column. That is very important. From this F column mean is coming or this XI column mean is coming. Means XI is the observation, right? One of the observation only will take it as a mean. Okay. That mean, but before even finding the mean, we can assume some values as mean. Okay. And we'll do calculations accordingly. Okay. Now here we can assume any value as a mean. Even from the first value or the last value you can assume. But what I suggest is, what we usually follow is, the middle value they always take. Okay. So middle value in the sense, here we have 1, 2, 3, 4, 5, 6. Then from these two, any one we can take. Why middle value? No? Then only the burden will be reduced. Or else again numbers will be bigger. Okay. In your book they have chosen 47.5, I guess. Is it? Now we'll take 62.5. We'll see what happens. Okay. Now we have to take, assume A is equals to 62.5 as mean. Okay. Now after assuming it, okay, we have to find the mean deviation mean. DA is xi minus A. Okay. That means we have to subtract each of the observation from the assumed mean. Also, for this step also, you don't need to actually subtract. What you can do is, actually 62.5 minus 62.5, what will come when? 0. Is it? And then, above and all, we can put the class size in negative. Multiples of the class size. So, it is minus 15, minus 30, minus 40. You don't need to worry. Sorry, minus 45. You don't need to worry. Because when you actually subtract also, same value will come. You just check whether 62.5 minus 47.5 is what? Oh, sorry, my bad. Again. It's not. Xi minus A, right? Xi is 47.5 minus 62.5. When you subtract, what will come? It's minus 15, right? Subtract and check, man. You all are human calculators, I know, but do it with the pencil. Come on. Minus 15 coming or not? Check. Coming or not? Yes. Likewise, this also automatically will come. We don't need to waste time on those things, calculations and all. Simply remember this, but don't get confused with these things. Here, we have to add the class size for xi's. Alright. And when you find di's, we'll put 0 near to the assumed mean. Above and all multiples of the class size with the negative. Below and all multiples of the class size with the positive. Okay. Now it is easy to multiply them, is it? So instead of finding Fi(xi), now we will find Fi(di). We are multiplying Fi with di. Multiply them 2 times minus 45, which is minus 90. 3 times minus 30. Easy to multiply, is it? Minus 90 again. 7 times minus 15, which is 70, 35, minus 105. 6 times 0, 60, is it? 6 0. And then 6 times 15, 60, 30, 80. And then 6 times 30, 180. That's all. Sigma Fi(di). Add everything. Minus 90, minus 90, minus 180. Yeah. With this plus 180, it will vanish. 105 minus 80. How much it is? 25. Minus 25. Is it? So that is what Fi(di). How much is sigma F, man? How much is sigma F? Add everything. 18, 20, 30. Yeah. Okay. Now apply in the mean formula. The mean formula is A plus, see, assumed mean, A plus sigma Fi(di) by sigma Fi. Substitute these values. What A value we have chosen? Yes, sir. 15 into 6, 90. Yeah. Oh, yes, man. Sorry, my bad. 60. Oh, yes, yes. Then minus 35, man. Sorry, minus 15. Correct? Correct? Good. And then A value what we have chosen? 62.5 plus Fi(di). How much we got? Minus 15 by totally how much, man? Fi, which is 30. Simplify them, then we'll get 62.5 minus 1 by 2. 1 by 2 means how much? 0.5. 62.5 minus 0.5. How much it is? 62 is the mean. Previous method, what we got as the mean? What, man, you're doing magic and all. Previous method, what we got as 62 only. Okay. Got it? Any doubts in this method? Also, these tricks and all, mark it with your pencil. Okay. In your own understanding manner, take the pencil, make a note about this column. Put one arrow mark. See here, only assumed mean 0. Above that, multiples of class size in negative. Below that, positives. Like that. Okay. So, no doubts in it, right? The next method we'll see. That is called step deviation method. Okay. Step deviation method means one more step ahead. Shall I erase this? You guys have copied or not? Okay. Step deviation method means we'll go one more step ahead. It is also same as see, now you see, step deviation method means same as this method only, man. We'll take the assumed mean as 62.5 Okay, and we find the step deviation, mean deviation. We call this is the mean deviation because from the assumed mean we are getting the deviation differences. That is why we call this is mean deviation. And then after this also we find these numbers are big. We can't multiply. Like big numbers will come. This case it is okay, but in some cases it will come like somewhat big number. So to reduce that burden further, see initially some numbers are given. We found that numbers are bigger, so we can't calculate easily. So we reduce that burden by assuming one of the value as the mean. We found the mean deviation. Correct? Now again, this number is also big like we think. Then what we can do means we can go with one step ahead. It is called the step deviation method. So step deviation method means after finding the mean deviation, the DIs and all, we just divide it by H-man. That we call it as UI. Okay. That we call it as UI. That is di by h. For this also you don't need to struggle. Simply near to the 0 you put 0. Okay. Above that and all minus 1, minus 2, minus 3. Below that and all what it is positive 1, positive 2. That's all. If you actually divide also the same answer will come. Okay. There. Don't get confused. H is 15, man. See, we have the class size 15. Okay. When you divide this by 15, what will come? Minus 1. This is minus 2. That is minus 3. Alright. After finding UI, then we can find Fi UI. That means Fi with the newly found value. Okay. To avoid confusion, you better mark in the pencil like this. Because what happens means people will sometimes multiply with this for the first observation. And from the second observation onwards, they will multiply with this. Okay. So to avoid these mistakes and all, simply put an arrow mark from what we are multiplying what. Fi, Ui we have to multiply. Sometimes the clever people what they do means Xi and Ui and all they will multiply. The idea is to reduce the burden, not to increase. Okay. So simply multiply 2 with minus 3, that is minus 6, and then 3 2s are again minus 6. 7 into 1 minus 7. 6 into 0 which is 0. 6 into 1 which is 6, and then 6 2s are 12. Add everything. Plus 6, minus 6, 12 and all gets cancelled. Remaining we have minus 1 alone. That is what? Sigma Fi Ui, which is minus 1. Now the formula, man. What is the formula, in the step deviation method? A plus H into sigma Fi Ui by sigma Fi. Usually they will say the H after this only, but there is a chance that we may miss that H. That is why I am using H always in front. Okay. So now here substitute these values. So x bar is equal to A, this is the assumed mean, same as the last, and then plus H is 15, and then Fi Ui is minus 1 by Fi is 30. Then simplify this, man. We have the 62.5 minus 1 by 2, which is 62.5 minus 0.5. So the answer is 62. See, we have done the same question in 3 different methods. Also, in your book, they have done by choosing this 47.5 as the mean. They also got 62 as the mean. We also got the 62, same as the mean. Okay. So the thing is, we can choose any of these values, still we get the same answer. Alright. Clear? Any doubts on this, man? Also, be aware of this DI. For writing class, Xi is what we have to do. Xi trick is what? Remember? First one only we should find actually, exactly, correctly we have to find. After finding it correctly, add the class size. To reduce burden, easy calculation, quickly we can do. For that I am saying. Otherwise, if you are not sure, you are confused, better do class marks for all the class intervals on your own. Okay. And then for DIs, you know what it is? The same class size only, with the negatives you should write above, with the positives you should write below. Also, the mean, assumed mean can be chosen any of these xi's. Okay. Don't choose fi as the mean and all. Answer will not come. Okay. Clear? Shall we go to next one? The median. Okay.